Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of NEET Preparation, we'll be looking at previous year questions of physics in medical entrance examinations in India. Today we're dealing with the chapter Motion in a Plane. This is the third chapter in the grade 11 syllabus for physics in CBSE. So, there are a lot of questions from this chapter, and today we're going to be looking at some of them. Here's the first question of this episode. If vectors p bar equals ai cap plus aj cap plus 3k cap and vector q equals ai cap minus 2j cap minus k cap are perpendicular to each other, then we need to find the positive value of a. Is it 0, 1, 2, or 3? How do I solve this question? Now, it's given that both these vectors are perpendicular to each other. That means the dot product of these two vectors must be equal to 0. So the dot product of p and q is 0. So ai cap plus aj cap plus 3k cap times ai cap minus 2j cap minus k cap equals 0. So therefore, now we will be using the working rule for dot product. So according to the working rule, the dot product of two vectors can be written down as a1, a2 plus b1, b2 plus c1, c2, where a1 and a2 represent the x components of both vectors, b1 and b2 represents the y component of both vectors, and c1 and c2 represents the z component of both vectors. So using this working rule, we can write that a times a plus a times minus 2 plus 3 times minus 1 equals 0. That means a squared minus 2a minus 3 is equal to 0. So this is the equation that we get with respect to the working rule. Now, let's split the middle term of this quadratic equation to get a squared minus 3a plus a minus 3 equals 0. Taking a minus 3 common, you'll get a minus 3 times a plus 1 is equal to 0. That means the final answer that we get is a equals 3 or a equals minus 1. But remember that minus 1 is negative, and the question is asking us to find the positive value of a. So option D, 3, is the right answer for this question. A is equal to 3. Now let's look at this question. The maximum range of a gun across a horizontal terrain is 10 kilometers. If g equals 10 meters per second square, what must be the muzzle velocity of the shell? So we need to find the initial velocity u here. So now we use the formula r equals u squared sine 2 theta divided by g. But however, the question is stating that the maximum range is 10 kilometers. For maximum range, r max, sine 2 theta must be equal to 1. So therefore, r max will be equal to u squared by g. And the value of that quantity is given as 10 kilometers. So 10 into 10 raised to 3 meters is equal to u squared divided by 10. Therefore, you can find out that u squared is equal to 10 times 10 times 10 raised to 3, which is equal to 10 raised to 5. Now that we've found u squared, let's take the square root. So taking square root on both sides, you'll get u equals square root of 10 raised to 5. So u equals square root of 10 raised to 5. we can write 10 raised to 5 as 10 times 10 raised to 4. The square root of 10 raised to 4 can be written as 10 square outside the root, and inside the root we'll write a 10. So the value of u is 100 root 10. So therefore, the right answer is option C, 100 meters per second. This is the next question. A projectile can have the same range r for two angles of projection. If t1 and t2 be the times of flights in the two cases, then the product of the two time of flights is proportional to. So in this question, we have a projectile and it is shot at two angles, and it is said that the range is the same. So for same range, the condition is that the two angles must be complementary. Now, what does complementary mean? It means that the sum of both these angles must be equal to 90 degrees. So therefore, we can write one angle as theta and the other angle as 90 minus theta. Now the formula for time of flight, t, is 2u sine theta divided by g. For time t1, the formula is 2u sine theta divided by g, taking the first angle as theta. And for time t2, the formula will be 2u sine of 90 minus theta divided by g. Now what we can do is we can write sine of 90 minus theta as cos theta. So t2 will be equal to 2u cos theta divided by g. We need to find the product of t1 and t2. So t1 times t2 is equal to 2u sine theta by g into 2u cos theta by g. So 2 times 2 is 4, u times u is u square. We have sine theta and cos theta on the numerator, and in the denominator you get g square. So what we're now going to do is we're now going to write this as 2 times of u square times 2 sine theta cos theta divided by g square. So that is equal to 2 u square sine 2 theta divided by g times g, which is g square. So let's take 2 by g outside. The remaining terms, u square sine 2 theta divided by g, that is equal to the range. So therefore t1 times t2 is equal to 2r divided by g. Therefore t1 t2 is proportional to the range. So the product of the two time of flights is proportional to option C, the horizontal range, powered 1. Let's look at this question. A car travels 6 kilometers towards north and at an angle of 45 degrees to the east, and then travels a distance of 4 kilometers towards the north at an angle of 135 degrees to east. How far is the point from the starting point, and what angle does the straight line joining its initial and final position makes with the east? So let's first draw the lines in this question. So we have north, east, west, and south. So in the first case, at an angle of 45 degrees, a car moves 6 kilometers east. 6 kilometers north, So it's traveling north at an angle of 45 degrees to the east. So if you take the angle, you take it from the east and move counterclockwise 45 degrees. Next, we have the car turning, and it is now moving at an angle of 135 degrees from east and also going in the north direction. This time, the distance traveled is 4 kilometers. What we need to find is the resultant r and the angle that it makes with the east direction. So you need to find the resultant and also the angle that the straight line makes with the east direction. So how do we solve this question? In this question, we need to write the components of both of these distances. Since they're not in the x or y axes, we need to find their x and y components. So the distance along the x-axis is equal to 6 times the cos component, that is cos 45. And since the since the other distance is moving to the left, that means it's moving backwards in terms of the x-axis. You subtract it, so that is 4 times cos 45. So 6 minus 4 is 2, so 2 times cos 45, that is 2 times 1 by root 2, which is equal to root 2 kilometers. So the distance along the x-axis is root 2 kilometers. What about the distance along the y-axis? The distance along the y-axis is, you have to add the y components of both these distances in order to get the distance along y-axis. So that means you get 6 times the sine component, 6 times sine 45, plus 4 times sine 45. That is equal to 10 times sine 45, which is 10 times 1 by root 2. That is 5 root 2 divided by root 2, which is equal to 5 kilometers. I mean, if you look at it correctly, it's 5 times 2 divided by root 2. So therefore, that is 5 root 2 kilometers. So the distance along the y-axis is 5 root 2 kilometers. Now that we've found the distance along the x-axis and the distance along the y-axis, we need to find the total distance. The total distance traveled will be the resultant. So to find the resultant, we add up both the x and y components. We add up the square of the x and y components, and then we take the root. So the distance along x-axis, the whole square, plus the distance along y-axis, the whole square, and this sum is under a root. That is the resultant distance. In this case, it is root 2 the whole square plus 5 root 2 the whole square, and all of that under a big root. Root 2 the whole square is 2, plus 5 root 2 the whole square is 25 times 2, which is 50. So therefore, root 52 is the total distance. So the distance r is equal to root 52 kilometers. So now that you've found the final distance, we need to find the angle with respect to east. So in order to find this angle, we take the tangent of the angle. The tangent of the angle is equal to y by x, the y component divided by the x component. That's because if you look at the diagram, then you see that the angle it makes here is theta. This will be the opposite face, and this will be the adjacent face. The opposite face is along the y-axis, and the adjacent face is along the x-axis. So therefore, y component by x component gives you tan theta, which is equal. So now y by x is equal to 5 root 2 divided by root 2, which is equal to 5. So tan theta is equal to 5. Therefore, theta is equal to the tan inverse of 5. So root 52 kilometers and tan inverse of 5 is the right answer. And if you look at our options, you find that option C gives you the correct option. The correct angle and the correct distance are shown by option C. This is the final question of this episode. If two forces of equal magnitudes act simultaneously on a body in the east and the north directions, then the body will displace in the north direction, the body will displace in the east direction, the body will displace in the northeast direction, or D, the body will remain at rest. So, let's consider an object O, and it has two forces acting on it. One force is along the north direction, the other force is along the east direction. Let's say that the magnitude of force is capital F. So as you can see, these are two adjacent vectors and they are also co-initial. So therefore, according to the parallelogram law of vector additions, the resultant will be in between the two vectors. So if you happen to draw a parallelogram, then you can see that you can draw the other two sides, and you can see that one of the diagonals of this parallelogram, the diagonal that is hitting the co-initial point, will give you the resultant vector. So if you see that the resultant vector, it is present in between the east and the north directions. So therefore, option C, the body will displace in the northeast direction, is the right answer. If you want the body to displace in the north direction, then the magnitude of force here must be greater, which in this case is incorrect. For option B to occur, the magnitude of force along the east direction must be greater, which is also incorrect. For option D, the body to remain at rest, either both of these magnitudes must be equal to 0, or the direction must change. If the direction is, say, north-south or west-east, then if you have forces of equal magnitudes, then the body will still remain at rest. So therefore, option D is also incorrect. The right answer is option C, the body will displace in the northeast direction. And this we found out using the fact that according to the parallelogram law of vector addition, the resultant vector will be in between the two vectors which are co-initial. So that concludes this episode of NEET preparation. For more of our videos on NEET preparation, you can always hit the playlist given in the description down below to receive more of our videos. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.